Today's lesson video, we are going to look at chemistry 1501. This is empirical formula and molecular formula. We will be focusing on examination preparation. This is lesson 101. Let us start. Before we get to the lesson, let us go through how to use this lesson video. This lesson video is not the same as other lesson videos. This lesson video, it goes hand in hand with a worksheet, which is in a format of a document. So before you answer questions from the document, make sure that you watch the lesson video. In this lesson video, I'm going to provide many examples. So how do we use this lesson video? You will watch the first example and look at the procedure, look at how we calculate the empirical formula. And then from there, the second example, you pause the video. Once I display the question, you work out the example and then you play the video to verify your answer. Same goes to question number 3, question number 4, question number 5, until the end of these questions. So that is how we master a concept. Once you are done with these examples, then you will be good enough to look at the worksheet and answer the questions. Once you answered all the questions in the worksheet, then you'll be ready for the examination. You might move on to the next lesson. If you don't have any lesson 102 or the next lesson for this topic, it means by that time you are done with the worksheet, and then we look at how you answered the question, your performance. That means that you'll be covered with this topic. You don't have to create a lesson 102. This lesson video is basically created for those who are under examination preparation for this year under chemistry 1501. Now let us look at the first example. We are going to calculate the empirical formula of the compound which has this mass percentage, which is 88.8% of copper and 11.2% of oxygen. Now for the worksheet, don't expect questions which are summarized like this. Expect a scenario, but you will see these figures here. So this is just a lesson video. You're going to focus on the procedure. Now what I normally do, since we have two elements, we are going to tabulate. Having a table with two columns. Now here we have 88.8% of copper, and here we have 11.2% of oxygen. Now looking at the steps, the first step, if we are given the mass in percentage, we are going to convert the mass in percentage to grams. That is step number 1. We are going to convert this percentage to grams. And then step number 2, we find the number of moles. Number of moles using this equation. Then this is the mass of a substance in grams. This is the molar mass of the substance. Step number 3, we are going to divide all the number of moles that we calculated in step number 2 by the smallest number of moles we have amongst all the elements that we are given or that we are calculating. And then from there, we are going to look at step number 4. After dividing by the smallest number of moles, we are going to round off to 2 decimal places to check whether there is a number that surfaced as something 0.5. If there's no number, we are going to round off to the nearest, and then our final step, that is where we are going to write our empirical formula. So let us go ahead and go through the steps. Now we said the first step we are going to convert from percentage to grams, so we are simply going to change this symbol to grams, and then from here we are going to calculate the number of moles using our equation. So the mass of copper is 88.8 grams divided by the molar mass of copper is 65. Oh no, it's not 65, it's 63. Let me erase this. 63.55. Then let us do the same thing to oxygen. We have 11.2 divided by 16.00. We get that our number of moles is 1.397 mole. So this is the first number of moles. You can say the first number of moles. For oxygen we have 0.7 mole. So this step is the first number of moles. Now how do we calculate the second number of moles? We are going to compare the two. Which one is the smallest? We can see that 0.7 is smaller than 1.397. So we are going to divide both sides by 0.7. So whenever you calculate the number of moles for the first time, just make sure you round off to 3 decimal places, at least 3 decimal places. This will definitely be 1. And then this is 1.995, rounding off to the nearest. Or if we can start by rounding off to 1 decimal place, we're going to get 2.0. So it's simply 2 mole. So when we calculate the number of moles for the second time, remember that you start by rounding off to 1 decimal place, meaning that one number after a comma. Then if it happens that there is a number something 0.5, don't round off to the nearest. You'll write that number something 0.5, it might be 3.5, 2.5, 1.5, and then we are going to multiply each and every term by 2. But since there is no number that appears as something 0.5, we are going to write it the way it is. So the empirical formula for this compound is CU2O1. This 2 is this one, then 1 is this one. So this is the empirical formula of the compound that we are referring to in this example. Let us go to the second example. Let us look at this example. We have 3 elements in this case. So let us go ahead and draw our table consisting of 3 elements. So we have carbon, which has 40%. We have hydrogen, which has 6.7%. We have oxygen, which has 53.3%. So in this case, we know that the mass of this will be 40 grams, 6.7 grams, and 53.3. Let us go ahead and calculate. N is equals to, we know the equation is m over m, so let us just go ahead and substitute. Carbon is 12.01, then we have hydrogen 6.7 over 1.008, and then oxygen 53.3 divided by 16.00. So we get that 3.330 mole, 6.647 mole, 3.331 mole. So in this case, you compare which one is the smallest. You can see that this is small. It's the smaller number of moles, so we are going to divide by 3.330. Also here 3.330. So here we are going to get 1. This one is 1.996, which is the same as 2. When you round off to the nearest, then this will give us 1. So the empirical formula for this compound will be C1O no, C1H2O1. I hope you got it correct. For the sake of practicing, let us look at another 2 examples. Now pause the video and try to work out this question and play the video to verify. So we have N and oxygen. So N is equals to 30.4 divided by 14.01. Let us quickly do the same thing here. We have 69.6 divided by 16.00. Rounding off to 3 decimal places, we have 2.170, 4.350. So you are going to divide both sides by 2.170. Then we get 2. So this will be N1O2. This is the empirical formula. I hope you got it correct. Let us look at the last one. Pause the video, work out, play the video to verify. So we have P and BR. So N is equals to 7.19 divided by, let us quickly do the same thing here, and 2.81 divided by, for phosphorus is 30.97, for bromine it's 79.90. For bromine we get 1.62, so we divide both sides by a smaller number. We actually get 5. So the empirical formula is P1BR5. I hope you got it correct. Now that you know how to calculate the empirical formula, let us go to the molecular formula part. So in order to find the molecular formula, we need to first find the empirical formula. But the question, if it will ask you based on molecular formula, it must give you the molar mass of that molecular formula. In this case, let us take that the molar mass is 92 grams per mole. So we did calculate the empirical formula, and then we found that this is the empirical formula. We know that the empirical formula is the smallest ratio of a compound or a molecular formula. So meaning that this empirical formula can yield many molecular formulas. Since it is the smallest ratio, just know that it can be N2O4. If you multiply these numbers by 2 I mean, it can be N3O6. Well, it doesn't matter whether this type of compounds they do exist, but what I'm trying to say is that an empirical formula can have many molecular formulas. Or we can have N4O8. So we need to calculate the empirical formula with respect to this molecular formula. I mean molar mass, not molecular formula. So we are going to find the molecular formula using this molar mass. So according to the question, this molar mass is the molar mass of that certain molecular formula. So we need to determine that molecular formula. We are going to use this equation. R. R stands for, let me say it's a ratio. We are going to take the molar mass of the molecular divided by the molar mass of the empirical formula. So we are given this, we should calculate this. How do we calculate the molar mass of the empirical formula? Since we have this the empirical formula, we can go ahead and calculate the molar mass of NO2 by taking the molar mass of nitrogen, which has 1 atom, plus 2 atoms of oxygen. Nitrogen from periodic table is 14.01, and then oxygen is 16.00, which we get 46.01 grams per mole. So in this case, we are going to take the ratio of the two. So R is equals to the molar mass, it's 92 over the molar mass of the empirical formula is 46.01. We get 1.99956, which is round off to the nearest, it will be 2. So this is the number that we are going to multiply our empirical formula to find the molecular formula. So it will be 2 multiplied by 1, it will be N2O, 2 multiplied by 2, we are going to get 4. So this is the molecular formula. Pause the video, work out this question, play the video. A certain compound has the empirical formula of C5H4, and the molar mass of that certain compound is 128.16 grams per mole. Calculate the molecular formula of this compound. Now we said we need to calculate the empirical formula, the molar mass of the empirical formula. So we have 5 of carbon plus 4 of hydrogen. Carbon is 12.01, oxygen is hydrogen is 1.008. We find our molar mass of the empirical formula is 64.082 grams per mole. So in this case, we are going to find our ratio, which will be 128.16 divided by 64.082. In case you tend to forget, or you find yourself in a situation whereby you forget the equation, just know that in most cases it's big number divided by small. So just calculate the empirical formula of the molar mass of the empirical formula. You compare these answers, then you'll see the big one will come to the numerator level, the small one to the denominator. Then we'll figure out the ratio. We still get 1.9999, which is 2. So multiplying this by 2, we are going to get C10H8. This will be the molecular formula. For our last example, we are going to look at this one. In most cases, it appears in the examination. In this case, we are given the percentage of one element. A compound consists of iron and oxygen. We are not given the mass percentage of oxygen in the scenario. So you should know that whenever we add the two, they must give us 100. So we start by calculating our mass percentage of oxygen. You should know that the mass percentage of iron plus the mass percentage of oxygen, it will give us 100%. If we have three elements and then you're given two, so you are going to have the sum of three elements adding up to 100%. So in this case, we're given as 70.0% plus percentage of oxygen. Note that when you transpose, it will be 100 minus 70.0, which the mass percentage of oxygen will be 30.0%. So if it happens that you come across a question like this, you will know what to do. So in this case, we can go ahead and calculate the empirical formula. You can quickly do it. N is equals to 70.0, N is equals to 30.0, iron is 55.85, oxygen is 16.00, 1.253 mole, 1.875 mole. So you're going to divide by 1.253. And now N is equals to 1. Then we are going to get 1,496. So this is the scenario, or let me say, this is the situation I was talking about. When you round off this to one decimal place, you are going to get 1.5. In this case, it's a number something 0.5. Something 0.5. We don't round off to the nearest. What we do, we are going to multiply all this number of moles by 2. So you multiply this by 2, multiply this by 2. So N will be equals to 2, and then our N will be equals to 3. So the empirical formula will be Fe2O3. Now this is the end of our lesson video, but before we start with our discussion, like I said, you should watch this lesson video. Our first activity before looking at our worksheets, this will be the first activity. Prove that the molecular formula of a compound that consists of 39.97 of carbon, 13.41% of hydrogen, 46.62 nitrogen, 46.62% of nitrogen, with the molecular formula, the molar mass of 60.10 grams per mole is C2H8N2. So just prove that the molecular formula of a compound that consists of this mass percentage with the molar mass of this is equals to this. And then this will be your first activity. Before you open the discussion, you'll be expected to show your workings, proving that this is the molecular formula of this mass percentage of these elements with the molar mass of this. That's it for this lesson video. This is Bahula SJ. Thank you very much.